So, hello again. This is the second part in our tutorial for writing a text editor from scratch, basically covering all the little steps that you might care about if you have no idea on how to approach this problem. We already created a simple application where we can type in text and delete and add characters. And today we will try to replace the rendering part, which right now uses the Windows specific GDI library, which is not very good. So we will try to use software rendering, and I will try to go through all these steps today and see how far we get. So without further ado, what I did is also I copied the text we had from last time to a new folder so that if I ever want to upload this, I can you can see the progress from each video into its in its old folder. So it's just a straight up copy with a new name, and I will be starting to work on this instead, which I probably didn't do when I loaded up the editor. So let's switch to the new folder and go over some fixes first, some stuff that I messed up basically. So as you can see, I defined the U64 wrong because it needs to be long, not long int. Long int basically maps to 32 bits also, so it's a bit redundant, but it's basically to support some older hardwares which had more exotic byte counts. I personally prefer using the MSVC built-in types like something like int8, and then rename those to the shorter versions that I prefer. Also, I like to have null as in small case instead of capital. So this is basically one of the main errors I did. Something like this. The next point is I want to fix the macro which generates strings for us. If you look at this code here, my music is still too loud. If you look at this code here, if you pass in a string literal, it will, I'm just looking at chat. Okay, so as you, we expect here string literal, and string literals are zero terminated. So even if you pass in something like this, it will always have a length of 1 byte because of the zero terminal character. But we don't care for that, so I will artificially reduce the count by 1 so that we do not include the zero terminal character. This way, basically, strings will work the same way whether or not we create them from some literals in the C++ code or if we were to read it from a file. So next step is we want to replace GDI with software rendering. Now, wouldn't that be fun? So basically, in order to do so, first, I have some steps. Like I want to clean up the register class stuff so that we can use double buffering. And for that, we need the choose pixel format. So I will cheat a little bit and go look at some older code that I have. Just have to find it. I can't find it here. No. I thought it should be here. Do I spell it wrong? We have some technical difficulties. Sorry, today I'm a little bit slow, so I apologize in advance. I can't seem to find the proper place. Maybe I'm not using it here. Where did I put this? People. What is here? It was here, right? No. I can't find it, so we will Google it. So I should start a new one. So let's see if Google will play nice with us today and we get English text. Yeah, it seems so. So basically, if we want our windows to also have double buffering, we have to specify a so-called pixel format. And we also need to add some additional information to our window class to support that. Let me just think very quickly because I am kind of unfocused now. I don't know why. So bear with me. So where do I have this code? This is a little bit annoying. I had it here. You can see I'm very unprepared. Was it an OpenGL? Maybe it was an OpenGL. Wouldn't surprise me. Okay, yeah, this seems like the proper place. So basically, this is the information we want to fill out. And for that, we have this pixel format descriptor struct, which has a lot of information, but we don't need all of them. So basically, these are the ones that we need. First of all, in order for Windows to identify which version we are using, it is common for some of the API calls to fill in the struct size as one of its parameters. Internally, Windows will then know which struct it will refer to if there was upgrades where maybe there were some additional fields. So basically, you have to specify the size. Then you have this version, which is always 1 because they never updated it. But that was kind of the way to future-proof it, I guess. And this is part where we can set up the double buffering, basically, or also enable OpenGL support, which we don't need for now. And then we can specify what kind of data the frame buffer will have. Like in our case, we want RGBA data, how many color bits. So it's going to be 32 bits, 8 bits per channel. Then you can specify depth bits and stencil bits, which is also part of the original OpenGL API. You don't really need that if you use a more modern version. And then you set this layer type, which will always be the main layer. So if we look at our code, there are 2 calls to do that, to set this pixel format. The first one will get a proper pixel format for us from this descriptor. So basically you're asking Windows, give me some pixel format that has this requirements, that meets this requirements. And we can check whether or not that worked. If it didn't work, we get 0 back and we can return an error. Couldn't set up, couldn't. And we will just return. Usually I would make a function for that, but that's not really the point here. And after that, you can basically just set this format. So you first choose, then you get this index back, and then you can set it, and you have to specify the pixel format descriptor again. And now this device context is a thing that we didn't get yet, because we take it in our paint message, if you might recall, like so. But we want to have it globally to our window, so there's another step that we need to add to our window class. So I'm sorry if this is a little bit out of order. here. Exactly. So basically, last time I specified the minimal requirements to register a window class, but there are some more that you might want to have for more modern rendering. For instance, yeah, well, you can always specify the background color. That's not important. But the style is important because we can say this window owns its device context. So we don't have to carry it every time and then release it every time, which is what we do in our VM paint here. We always get the device context when doing begin paint, and it will be released afterwards. But now we can just carry it after we create the window, and we have it permanently because our window basically owns this device context. And as you can see, the pixel format stuff requires the device context to function. So after we get the window handle, we can get the device context just by calling get DC on the window handle. As always, you should check if this function actually succeeded. I would wrap that in some kind of call that you can just wrap the function around, but right now I'm doing it manually, so couldn't choose pixel format. That's good language right there. So then we have the device context, and this will never change throughout our application. It's associated with our window, and now we can use that to set up the pixel format. So as you see, this is basically another crucial line that we missed, and also telling the application what kind of cursor we want to use. I'm going to do a quick replacement of all my nulls to lowercase nulls, just because this is what I prefer. Feel free to ignore that. So okay, unnecessary indentation. Okay, so we have done all that. This can also fail because it's Windows. Why shouldn't it be able to fail? But typically, if the other call succeeds, this one won't fail. But hey, just for the future. So also we should return an int, because that's what our main function expects. Haven't compiled yet, so let's see if I've made some stupid mistakes. Window handle. Also, yeah, it's called HDC, not RC. And now you can see that we have two more functions that need special libraries in order to work, while the function signatures are defined in Windows 8. The implementation is defined in some libraries. So if we copy the name of the function that is missing, search for it, and look further down, we can find which library we should include. In this case, it says we should include GDI32lib, which I think I already did, but maybe I removed it. Oh yeah. So basically we just add this new library, and then it should build. Yay. And we should be back to feature parity. Oh yeah, I don't have a run command, which is something I have for my normal project, so forget it all the time. So everything works just as previously, but now we have double buffering. But we just don't use it yet. So next thing on the list, if we follow our nice agenda for today, is swap buffers. So we want to get rid of VM Paint and use swap buffers instead, so we can have double buffering properly. So previously we did all this in the paint event. So right now we want to move all this code so that we can just clear basically we write to some intermediate buffer, and then we blit that to Windows, and then we can just render without relying on paint events. So in order to do so, I just have to consult my code again because I have it somewhere and it was just a little tricky to set up like so. Basically, if we have to create a bitmap for Windows and specify some information on how it's set up so that we can write our intermediate buffer into it, and Windows can then basically display this bitmap buffer to the full screen. So first of all, we want some memory for our buffer, for our frame buffer. So again, I apologize, it's a little bit less structured than previously. So we're just gonna use something that we call a frame buffer. Software and a frame buffer, maybe. It has a width and a height. And it has some data associated with it. And this data should be an RGB8 format, which we haven't defined yet, but we will do soon. I just call it base because this is how I call other pointers for arrays and stuff like that. So we're gonna do struct RGBA. It's our expect all our pixel data to be 4 channels and 8 bits per channel. So we're just gonna say it's U8, which is red, green, blue, and alpha. And in order to introduce less typing, I'm gonna make a union out of it and wrap this around 2 structs. So basically, we have a struct where we have the full names, and we have another struct where we have shortened names like RGB, and the union will place them on top of each other, so we can access the red component with red or with R. I just prefer this. Also, we might want to access the whole thing as the value 33, or we might want to iterate over the individual values. Like so. And basically we just have 4 different ways to access the same data, however it is convenient for us. I prefer this. Yeah, you can do it however you want, but basically this is completely free. These are just all aliases of one another. So if it's not 32, it's just 4. So if I access something like values 8, 0, it's the same as if I would access the R component or the red component, for instance. And the U32 value 32 will allow us to copy the whole thing in one go instead of copying the channels individually. So we have this SR for software and a frame buffer. And now we want some memory for that. And because typically screen sizes are quite big, we cannot just allocate this on the heap. So we might want to get some memory from the operating system, like so. If we, you can use new if you like, but I'm just going to use the operating system's memory allocation, virtual alloc, and you specify some kind of byte count, like so. And all you need to do is call virtual alloc, and I will just go look at what I did here. So, and we can, as always, just look at the documentation. So basically, you have these 4 parameters. The first one is optional. It is a starting address that you can specify so that the memory will be mapped to a specific address range that you prefer. But if we specify 0, we just get some arbitrary starting address, however Windows decides. The size is the crucial part, which is the size in bytes that we want. And there are some flags like mem commit, which is what we will use. It basically tells the operating system that we want this data to be ready to use. We could also just reserve it, which indicates to the operating system that eventually we might want this data, but we are not using it right now and only commit it later on. But right now we will we just say commit because we want to reserve it and we also want to use it. That doesn't necessarily mean that the data will be given to you automatically. So basically, you get this address range, but it won't allocate any physical memory. Typically, only after you touch a certain address on part of this memory, it will allocate new pages in the background. So the first access might be a little slow when you go on to fill or to touch the first bytes in a page of this whole region, a page being something like 40K bytes. But you won't notice this because the operating system will handle it in the background as soon as you write to it. But after that, it will have allocated the physical memory for you. So any further access to the same memory region will be free, or just as free as normal RAM access. And then we have this other flag, which is this other field, which specifies how we intend to use this data. Is it this one, or is it? It should be the page ones, right? So we have these, and we will want to read and write the data, but you can actually mark pages of data as also execute access. So if you want to produce some assembly code, you can actually request Windows to be able to execute that data, but we don't need that. We only need to read and write from it. So virtual alloc will give us some base pointer, and if that pointer, however, is empty, which means we run out of memory, we will just again exit, which is maybe a little bit bad, but we can just exit the whole program, because we cannot just return here, since some portion of our code might just call this function, and if this function just returns, it will just continue executing the calling function, but we want the whole application to shut down if we run out of memory. So I'm gonna use the exit command for that, and it's just gonna call it so. Otherwise, we return the space pointer, if I spell return properly. And now we have the ability to allocate a frame buffer. So I'm just gonna allocate a big frame buffer. So we can just do something like this. And specify a width and a height. Height like so. And then we're just gonna call our platform allocate bytes function. And we're gonna say it's gonna be the width times the height times the size of RGB8 that we defined. We will create a frame buffer object, initialize it to 0, and then we will set the width and the height accordingly. Can't spell today. If ever. And then we're gonna set base address to whatever virtual alloc returns, but keep in mind virtual allocs will just return us some bytes, which is basically it would return you a void pointer, but I prefer to use U8 to indicate that's binary data that has no format specified to it. So we might want to convert this to RGB8 pointer, because this is what our base expects to be. And then we just return our frame buffer. So far so good. Now we can, after all this initialization process is done, we can allocate such a frame buffer like so. Frame buffer. and just give it some dimensions that we will make sure that any window size would fit. It doesn't really matter, so we can just say something like 2K by 2K basically, or whatever. And this should give us a valid frame buffer, or it will fail and call the exit function here, and this should result in our application shutting down without any warnings or whatsoever. So memory, undeclared identifier, where do we have that? So, oh yeah, this was copy paste mistake from my old code base. Oh yeah, so that works. I always keep doing that. So we now have allocated one gigantic frame buffer in the background, and now we want to fill it in with the proper data and then show it to Windows. So basically, also we assume that we cannot resize our window bigger than this dimensions right now. There are ways to get to the to get your actual monitor dimensions, and you can use that. But this is just a very primitive allocator, so we are not going to get into too much detail on this for now. So let's see, what is our next point in our agenda? We still haven't done any of this. Cool. So the next part is to fill this buffer with data and then present it. So in order to do so, we want to know how big is our window actually. So let's see. So if you remember last time, we had this peak message loop, which basically, as long as there are messages to be handled by our applications, will return true until we handle all applications. And after that, we will have some space or time available to do whatever we want. For instance, to do our actual rendering here. So in order to do that, I want to first know how big is the window right now, and then fill it up with some color, and then tell Windows to display that. So do we have some questions here? Okay. So in order to do so, we need the get client rect call, which will give us the region of the window, just for your understanding. The region of the window which excludes the border and the title and everything. So everything inside this window that we can render to. That's the client rect. And when we create the window, we specify the whole size of the window, including the border and the title and everything. So we, in order to get a specific client rect, we have to kind of create the window, see how big it is, and then resize it so that the client area will be the proper size. But we're not going to do that. Right now, we're just going to retrieve the size that we have and then adapt our frame buffer to that size and then display that. So as you can see, the call is pretty simple. All we need to do is pass in our window handle, like so. And then also pass in a rect struct. It's going to call this viewport because why not? And this will be filled out by Windows. And it can also fail because everything in Windows can fail. So you might want to wrap this. Which, by the way, is really bad API design. So if you watched Cake's streams on Vulkan, it's better to have some kind of callback that you can enable and debug that will trigger when you use your API wrong, instead of trying to guard against every function having the possibility to fail. It gets really tedious to wrap every function of your library into some kind of check, and it's also hard to read, and yeah, it's just not a good design. So we get this viewport, and then we get the width and the height. So we could make a frame buffer. I'm gonna call this sub frame buffer, for instance. We're just gonna copy our original frame buffer, but I'm gonna override the width and the height values. So we point to the same data, but we don't want to use all the data. We only want to use the data that fits on the screen. So we're gonna override the width with whatever viewport left minus. Okay, yeah. Maybe I should get into what this rect structure is again. So basically, it gives you left, top, right, and bottom coordinates, so you also know where your client region is relatively to the screen. So basically, we'll tell you this corner is the top left corner from this coordinates. This is the bottom left. This is the bottom right, and this is the top right corner. In Windows, coordinates go from top to bottom, so you can expect the bottom corner to be bigger than the top corner, and you can expect the right value to be bigger than the left value. So in order to get the width and the height, we subtract the right value from the left value to get the width. And we subtract the bottom value because that's bigger from Windows perspective, minus the top value to get the height. And also we want to make sure if we can actually display this. So we just to guard against this, we just gonna say we take the minimum of that and whatever is already in. So basically we cannot display more than our buffer allows to. So this is just a simple security measurement, basically. Then we have this subframe buffer, and we can write into it and try to display it. So first of all, I would want to try to display it, and then we gonna write something to it. So if initially there will be garbage in it, but that's fine. We just want to see if we can somehow make Windows show whatever we wanted to show. And in order to do so, I will just consult my code again, because I did this so many times and it's always a little bit tricky. If you want to just look at the Windows docs, it gets a bit messy. So I will use this function here, which basically just specifies a bitmap info that we can then use to tell Windows what to display, basically. So I'm just going to copy this, make a new function, call this, I'm just going to call this present, and I assume we pass in a valid frame buffer. And we want, frame buffer. Yeah, we want to make sure that our frame buffer actually has a width and a height. And typically they should also be positive, because in our case I specified the dimensions as signed values, just because typically when you use these values to calculate stuff, you typically will also use them with other signed values. And that's why I made them signed instead of unsigned, which is might seem more natural to you. But since we're going to be using coordinates inside this buffer that can be also negative, it's nice to have these dimensions to be signed to. So we have this, and oops. And because I just want to early out. So instead of checking whether both of them are bigger than 0, I just will check if either of them is less than 0. And in that case, I will just return and do nothing in this function, which should make the overall nestedness of this code a little bit more reasonable. So now we want to format a bitmap info so that it will point to our frame buffer data, and Windows then can use this bitmap info to operate on it and copy it basically in the background. So what we can look at the bitmap info data. This is basically also how the bitmap format is specified. So you will find, if you Google how bitmap is structured internally, it will correspond to this. So It's basically literally what is written in a file. But we have to specify our frame buffer as if it were a bitmap so that Windows can use it to display it properly. So this is how it would look. And since I already did the work, I will just go over it. So we initialize an empty bitmap info, and then we get a header information on top of that, which is also part of the bitmap. And why I do this is because basically I just want to avoid typing this all the time. So you can imagine that I can just replace the header info with this. And this was just for convenience, that I can access only the header info and only override the subset of information that is relevant to us. For instance, we have to specify the header size, which is given. Like it's always this size, but there are different bitmap infos that can have different sizes. Then we want to specify our width and height, which is basically what the frame buffer tells us. Then we want to tell it how many planes or layers there are. There's only one. And then we want to tell it how many bits per pixel there are. And the compression is RGB. It's just some format that it has. So this is essentially all we have to tell Windows in order for it to decode our frame buffer properly, because our frame buffer literally is just pixel data. Just pixel data without any weird form of encoding. Now we have the stretch di bits command, which basically, as the name suggests, you can specify a region where you want this bitmap to be stretched to on your window area, and you have to specify the source region of a bitmap that you want to copy, basically, and then we also specify what data we want. We will go over this right now. But basically, this also allows you to render to a lower resolution and then to upscale it to the window size if you want to support pixelated games, for instance. You get that kind of free. So if we look at the definition of stretch di bits. So yeah, you see all this information. You have the device context, and you have the destination region where you want the image to be placed in. In our case, this is just the full region, so it's 0, 0, and the width and the height of our client area. Then you have the source region that we want to copy into, which is also the same because our frame buffer should be the same size as our target window size. So it's also going to be 0, 0, and width and height. And then you have this bits, basically the pixel data that you want to copy, and then you need this bitmap info to tell stretch di bits how to interpret this this data. So, and then you have this usage, which is basically just usage is 0 in our case. I don't remember what that did. Mate. Oh yeah, if you have packed data, if your bitmap, for instance, has a palette, then you can specify this usage so that instead of every pixel being a color, every pixel would just be an index into a color palette, and Windows has to know that in order to recreate the proper color. And then you have the ROP, or raster operaization. In our case, it's just copy, but we can look at different ROPs. We use this one. Copies the source rectangle directly to the destination rectangle, but we don't really need any other one. So you can also copy the inverse or whatever. We don't need any of that because we will fill out our buffer internally however we like, and we just want Windows to display it as is. So again, we specify you can imagine you specify different values, but we assume that our window is just as big as our frame buffer. So it's just going to specify frame buffer width and height, 0, 0. Maybe make it a little bit more readable by specifying this in 2 different rows. buffer base is just our frame buffer base where our pixel data starts in. The bitmap info is the bitmap info we filled out here. And then we have this copy operation basically. And also this one can fail, because why not? Everything can fail in Windows. So you can guard against that if you like, just to see if something is wrong. Right now I haven't implemented any kind of asserts or something like that, so that's why I'm gonna do this manually, which is really not the point here. So, but I suggest strongly that you have some function to avoid all this redundant typing like I do. So, and then we exit again. So because somebody else could call this present method anywhere on the stack and we want to quit the whole application. This is something we don't need. So we have our present method. Yeah, that should be all. So we have our frame buffer, then we call present. We haven't filled the frame buffer yet, so it should show some garbage values. Present. We want to present our sub frame buffer because that might have a lower resolution than the maximum supported resolution. And then we can call swap buffers in order to tell Windows that we now want to render to the next buffer so that we can properly support double buffering. And swap buffers basically only requires our unnamed param1. Great. This is our device context. I don't know, maybe the documentation has some flaws. I assume it's auto-generated, so it might have been, they might have introduced some mistakes there, I guess. So we just specify our device context like so. And if this one fails, we can print a more reasonable error, which is swap buffers failed, and we can assume that the user has not enabled double buffering in their for their window. So in the pixel format, they might have missed this flag, and therefore swap buffers will fail because swap buffers assumes that there are two buffers. Enable double, something like this. So, and we will also exit here. Oh, in this case, we can just return because we are in the main loop, but you know what I mean. And let's see if after all this work, I don't know how long I've been going, but it took a while to get here. Oh, almost an hour, man. I'm so slow today. And we'll see if we get something to display on the window. First of all, we have to get rid of the errors with heights. So let's see. Another error, 132. This, this doesn't exist. We can specify the device context to present to, so we don't have to use get DC. Do we ever use it? Yeah, we use it here, down here. So this one is not necessary. So we need to specify our device context for Windows to know in which window, basically, to paste our frame buffer. Let's see. So it seems good, I would say. Chances are that the data from the frame buffer is cleared, but also we still have our paint call going on here. So in order to stop rendering the previous version, I will just comment this out for now so that we can just inspect whether or not our rendering works. And then we will slowly migrate that functionality back into our new frame buffer. So we have something, but don't know if it works. So, okay. Might work, might not work. We don't know. In order to check this, I will simply do something like, I will memset. I will have a RGB 8 clear color and initialize it with, I don't know, some magenta like, or no, it's turquoise, whatever color. I'm just gonna say wherever the frame buffer base is, I will set this clear color and I will use the value 32 because we know that every pixel has is also a 32-bit value. We can just use memset to override every pixel with one unique color, and then we have to specify how much we want to copy. I mean, how much we want to fill. So it's gonna be size of something like this. So let's see if that works. Oh, swap buffers failed. Enable double buffering. We see. Yeah. Oh, it just crashes. Okay. Well, I guess this is the time where we need to debug something. So we can start a Visual Studio debugger from the command line too, and with the call devenv, and then we can specify which program to debug. In our case, it's the main exe, which will set up Visual Studio properly so that we can just immediately run the exe and step through it without having a Visual Studio project. So what do we have here? No, I would load glyphs the same way you do with STB TrueType and essentially do what you do, more or less, but I would use a vertex buffer. We'll get to that. Maybe not today, because all I want to do today is basically get some simple replacement for the GDI working. And you see it's already been an hour, essentially. Concurrently. No, not concurrently. I wouldn't say that. So you see Visual Studio takes forever to boot up. It's still not ready. Yeah. Dude, are you kidding me? Man, I haven't used it on this user account, so I cannot debug. Thank you, Visual Studio. Thank you very much. Can I debug? Oh yeah, it gives me 30 days. I'm not totally screwed, so that's great. So basically, all Visual Studio does is create this solution where you have this main. Let's just look at it. If you look at the properties, all you can get is basically what's the executable and where do we want to call it. This is the working directory. And then you can say stuff like you want to attach to a running executable. Maybe you want to call the function and then also just start, the Visual Studio will figure out whether or not the process is running and attach itself to it so that you can debug directly. But we just want to call it here and then we see what happens or not. Oh yeah, this is a good point to tell you that we haven't generated any debug information, so we should do a quick, yeah, thank you Visual Studio command. So we should do a quick addition to our awesome build system. We want to enable debug and we want to enable what was generation of debug information, and we want to set optimization to debug. Well, this basically just sets up debug mode. This will tell the optimizer to not optimize, to use debug optimization, and this is will tell you that we want to use separate debug information, which it will generate this so-called BDB files, which then the your debugger can basically load and reason about source information and stuff like that. So if we compiled now with this new setup, and if we look at what was produced in the build file, you now will notice these two new files, which are program debug information, like generally for the whole project and then for your specific for your specific object file, for instance, our main object. It tells it says that's a 3D object, but it's just the .object extension, which is also typical waveform 3D object extension. But in our case, it's a compilation unit. So yeah, we'll see now if Visual Studio has more information available to guide us with debugging. So we run again. Yeah, so now we see assembly. Isn't that great? So we see our exe, and here it says we have an access violation. It points to this line, but it actually means the previous line. So whatever we do, our mem set is probably overwriting too much. So let's just see. Come on, give me some information, man. Okay, let's step into it because it seems like it lost its ability to track the information that we want. So we see the width is minus 642, which is not what we want. So I have calculated the width the wrong way around, which makes sense. As you can see, the right side is has the bigger value, so I have to subtract left from right. Thank you, Visual Studio, for pointing out this obvious mistake, but I wouldn't have thought about it otherwise. So all you had to do was basically add this 3 lines to enable debugging with all the proper information. So yeah, I'm not going to get into detail what these all do specifically, but this is basically optimization flag to tell you there should be no other optimization as for debugging. This is generation of debug information, which I think is implicit when you do /debug also. But you can leave /debug out and still have this flag on even if you do O2, which is basically the default optimization level, so you get some speed up. There are different levels of optimization. O2 is the most stable one to use, so that your computer just gets a little bit, your program just gets a little bit faster. So now let's get back to where we were. We have our code, and we did this very, very stupid mistake. And now, if we specify the proper dimensions, we see stuff. It blinks, but it's not what we would expect. Oh, also, I still have this sleep in here. We shouldn't need this any longer. So it still doesn't work. As you can see, I specified this color, but it kind of does whatever. But this can also be because Windows expects the bytes to be in a different order. So if I assume the first one is alpha and the last one is red, which can be the case, I will have to look that up. It might be that this was the problem. Now it's all white. I am a bit confused, to be honest. In order to see if anything happens at all, we want to, we can have 2 clear colors and just alternate between them on a frame-by-frame basis so that we see that it actually updates something every frame. You might not see it because of OBS, but trust me, it's there. Yeah, it's not quite clear, but I'm just gonna use all 0 and all 1, for instance, and see if I get a flashing background. So we have colors, and now all I have to do is keep track of which frame I'm in with the frame index, and just say something like frame index is 1 minus frame index, so it will alternate between 0 and 1. And then I will use whatever the frame index color is at that point. And you might not see it, but I will... what? It complains here because... suffix F. There is no suffix F here. Oh, yeah, there is a suffix F. What am I doing? So... oh yeah, so it does update every frame now, even without the WM paint event, and it flashes between black and white for me. But you might not see this. I'm just gonna check on the stream. Maybe you can see it. Yeah, it does. So this is now our proper frame loop, and swap buffers will also make sure that you kind of get you get double buffering. So now all this stuff that we did before with the VM paint event and invalidating the region and sleeping is no longer necessary, but this will still be rendering more than it needs to probably. But at least it's good to know that our frame buffer is not being ignored. The only thing that remains is to see what format it's gonna be. So I think if I consult my own code for a bit, I will see that basically I did something where I probably converted each pixel into a format that Windows will understand. So let's just look out for that. Do I ever use this? Oops. You see my editor is awesome. It failed and crashed. So lots of little bugs. So, okay. I am not quite sure, but let's just verify which channel is what. So if I just enable one of these channels, we should see one color. Where's my editor? Yeah, so if I slowly change each channel, we should get a feeling for which channel is which color, and then we know how to convert our internal format to a Windows expected format, which should just be the bitmap format, which I think is just flipped in order. And then we can do that. So now we have white. It's not what I would have expected. Let's see. What's else? Now it flashes black and okay. I don't see anything, so I will do this with the normal non-alternating version again. This was just for testing, so I'm just gonna clear this out again. So now I will use the normal version and just try to set each channel and see what happens. I'm pretty sure it's just flipped around. And we also might want to make sure that this values are actually correct. So this is 0. So I assume this one will be the alpha value anyway. So let's just try this. This is white. Doesn't make any sense. So I'm gonna use the debugger again, get in here and see if this color is actually set up properly. So what's the color? The color says red, green, 0, 0. So that makes sense. Okay, good. We have the buffer base, and then we have width times the height times RGB8. Okay. And then let's get here into the present. Right, 1 RGB. Maybe the header compression makes no sense. I'm not sure. Width, height. Just gonna Google this quickly. So what else do we have here? RGB, yeah. Red, green, blue format that is not compressed and does not use color mask. RGB format uses the, yeah, okay. So I'm not quite sure why it doesn't do anything then. So width, height. Am I presenting the proper thing? No, my union is fine, man. I just looked at it, so. I was also thinking about that. So I use the subframe buffer. I set the subframe buffer width and height properly. It just uses space. It must be filling the value properly. Just looking at this again because why not? Yeah, it's a 32 value, so we can just make sure that that the size is actually correct. So just if you're unsure about the size of a thing, why not just printf size of RGB8 equals %i. Sometimes you need some kind of sanity checks like these. Okay. Yeah, okay. Printf expects it to be an unsigned long, which is okay. So we have to specify the proper format. And here you can see the size is 4 bytes. This is exactly what we want. So, okay, this is not the problem. I'm not quite sure because I either see white always or I see black always, which doesn't make any sense to me. Now I see white. Now I see black. It is weird. So yeah, well, I'm pretty sure the format is flipped, and the alpha will be ignored. I'm pretty sure about that. But somehow it doesn't display anything but black and white right now, and I'm not quite sure why that's the case. Look at stretch bit parameters again. Yeah, why not? Could be a good thing to think about it. I'm just gonna look at the previous code also, just because I changed a lot of it. So was it here? No, it wasn't here. So if we look at the information side by side, we have this 0, size of header, frame buffer width, height, 132 RGB, okay. Then we have the device context, 0, 0, width, height. Then we have width, height again, because in this case I was able to use different things depending on what I want to copy. It is exactly the same thing, other than I'm not releasing the DC, but I don't really need that because I specified own DC, so that should work. Otherwise, all the other, otherwise this one would have failed also. We have this. And we have swap buffers. That's fine also. Maybe we should just step once through, because that's always the same thing to do. So we copy this, and we can also look at the data. This is 0, 0, 0, 0. This doesn't make any sense already, because our color should be this value. And it copies in 0, 0, 0, 0. Oh, yeah, I'm stupid. Yeah, that's actually pretty simple, because mem said while it uses an integer as value, it will only write bytes. So I'm stupid. I apologize, everyone. I'm stupid. I cannot just, I will always overwrite all the channels with the first byte I put in. So I'm stupid. We're gonna do the copy the proper way. So, which is also what we wanted anyway, but just, yeah, that was dumb. So essentially what we can just do is we have a clear color, and we can just do for usize e equals 0, I is less than width and height. Width times height. We can also use S32 because this is not gonna go anywhere probably. And then we can just say base I equals our clear color, like so. And then get rid of this. And now we should see something that's not quite white or black. Oh yeah, we have red. You can see if I specify this to be 0, this should just be the alpha channel, which will be ignored by the bitmap blit. Yeah, so you can see the format that Windows expects is basically not RGB, but BGR. So I have specified RGB, the blue value, to be 255, but it interpreted this as the red value. So before we can present this properly, we should always convert our buffer to be BGR. So that's pretty simple. All we need to do is take the value, and then we can say R is equals color blue, and B equals color red. Everything else is already in place. We don't need to swap that. We only need to swap these two. And now we should see blue. Yay, it's blue. So if I specify the color that I had in mind prior to that, like some kind of, this is yellow. Yeah, I wasn't thinking about it, but it should be yellow. Yeah, some muddy yellow, because it's only halfway through in the color. So now we have a way to display something else, and it also renders in it also renders in 30 FPS. So it also renders continuously without waiting for a message. So this is more like what you would see when hooking up your own rendering system. So all your rendering code, all your frame code basically happens after you process all the messages from Windows, and you don't have to wait for the WM Paint message. So basically we can just now use take all this stuff right here and place it in here. You can also place it in another function if you like. I'm just gonna put it in some scope so that we know that this code is meant to be the update code. So, and this now is the rendering part, and we can also scope that stuff because I prefer it this way basically. And yeah, this stuff is more or less platform specific. So yeah, I'm just gonna leave it like this. See. Fix some errors if we have errors. What is here? Oh yeah, the frame buffer. It doesn't know about the frame buffer because I scoped it here, of course. So I can just widen what's gonna be in the scope, like so, for instance. Now all this is concerned with rendering. And now we also have the functionality for adding and removing characters back, which was disabled prior to that. So if I type in characters, they will be recognized, but we don't see them because we're not rendering them anymore. The problem of memset is basically if you look at the signature, I can explain it quite quickly. So if you look at memset signature, if you can overcome the typing problem, memset wants you to specify an integer value and signed int, but we all know that integers are 32 bits, but memset will only use the first byte of this value. And I was trying to copy a 32-bit value, but it was also only using the first byte of this. So it was always using the red channel basically to fill up the whole buffer instead of copying 32 bits after another. If that makes any sense. And of course, I should have expected this behavior, but sometimes just you sometimes just don't think about it. So here you can also see it interprets it as an unsigned char, basically. But you can see that the interface is just bad because it suggests to you that the range that it accepts is bigger than the range that it actually uses. Yeah, so bad part on the C standard lib on that. But you know, it's 50 years old at this point, so yeah, we can do better now. So yeah, how far are we along? Yeah, I've basically been going for a while and we haven't done anything yet, which is bad, but it's a good stepping stone in order to replace our rendering. So what would be the next part in our agenda after I managed to do this? Honestly, I wasn't expecting to get pretty far in this one. So we have implemented fill rect, not really, but we should implement the fill rect and fill copy so that we can use them later on to render glyphs. So we have this present, then we can have something like fill or fill. I will call it fill box because I think of things as boxes instead of rects. Box is just a proper name. So we have our frame buffer. I'm just going to pass it by value because essentially it is only information on where the memory starts. It's not going to copy the memory. It's just going to copy the pointer here. And we are not going to change the dimensions. We're just going to change the content of the buffer. So that's why I can just pass it by value. Also, it's very small struct. Just like you. So we want to fill the box and we can specify some dimensions like X and Y, where in the frame buffer this starts, and then we can also specify a width and a height. And of course, we want to specify the color to fill it with. So all we really need to do is say X equals max between X and 0. So we do not allow negative values. Same goes for Y. And also we want to clamp the end. So yeah, we want to clamp that, and we want to clamp if, however, our X is still bigger than our frame buffer width, for instance, then we don't have to draw anything because it would be outside of the region. So we just return here. Same goes if our Y is outside our height, then we don't have to draw anything. And then we can just say and X equals X plus width, for instance. And then we can make sure that our and X is the minimum of whatever X plus width is, and the frame buffer width -1. No, frame buffer width. So same goes for y, only in respect to the y dimension. So on the height. And all we do now is say, I'm just gonna call it xit. It starts at x and it continues while x is smaller than end x, xit, I mean. And we're just gonna increment xit. So same goes for y. And we're gonna iterate over y first and then over x, because the rows are basically contiguous, and the rows are continuous and the columns are basically further apart of each other. So that's why we iterate over the y's first. Also, don't forget to add plus plus, otherwise you end up with a nice little infinite loop, which happens to me all the time. And all we do there is basically, we have our frame buffer, we have our base, we made sure that everything is in a valid region. Yeah. We didn't make sure that our frame buffer is valid, but that's something that I'm just gonna assume now, but you can add that with an assert that the width and the height is basically positive. Otherwise, this function doesn't make any sense. So all we do is we use base, and then we use the yit times the frame buffer width, which tells us how far each row is apart from each other in colors. And then we add xit to it. So it's basically like if that was a double dimension array, it would look something like this. But in our case, it's just a flat array, because we also want to make the width and the height variable on a frame per frame basis. And right now we're just going to copy in the color, which is not what we want to do ultimately. We want to enable blending, but right now I'm just going to copy it just to see if this function does the bare minimum. And now we can use fillbox to replace our clear color. To replace this loop, basically. So use fillrect, we specify our sub frame buffer, and we start at 0, 0. And we use the whole frame buffer width and height. Sorry, I keep forgetting to go full screen. So let's see if this works. Yeah, it still works. So, okay. First test passed. And now we want to fill in another color, add some smaller regions. Let's just say 2020, and oops. Our coordinates are 2020, and we want to make it like 100 by 100 or something. And our color is gonna be blue, for instance. And we'll see if now we have two rectangles. Hey, so basically this works fine, I would say, but we haven't tested what happens if we specify some negative values that are basically out of range. Let's try that. This seems to work, I would say. Not quite sure. Just to make it more obvious, I'm gonna go -50. As you can see, it doesn't work. So it started the X. Oh yeah, I see. So the first thing it did is, if you can recall, the first thing it did is basically clamping the X to the proper range. But in order to do so, we also have to reduce how much is going to be drawn. So it's not that easy. What we need to do is, if X is negative, we want to say that the width equals the width. We add X to the width, basically, because we know that X is negative. In other words, we subtract whatever portion of the rectangle would be outside of the window. So you have to imagine, because x is 0 is less than 0, this effectively subtracts stuff from the width. And the same can be done for the y coordinate. It's because you have to imagine if something is on the left side of the screen, our width and height of how much we are going to show on the screen will also be adjusted. So no dynamic loading weak. Yeah, it's true. So now you can see it's we only display half of the rectangle. We only fill half of it, which is what we wanted. So yeah, this is good so far. And the next step would be to copy a texture into a frame buffer. So if we have two frame buffers, we should be able to copy one region of the frame buffer to the other. And I don't think that we are gonna be able to get much more done today, but we can talk about it a little bit. It was a bit slow. It's very simple, straightforward software rendering. So I don't know how to call this function. Basically, I mean, blit is what's typically called, I would say. So we have a destination frame buffer, and we have a source frame buffer. And we want to essentially, we just want to specify where to place the thing and the dimensions and everything. Yeah, I'm not going to do this now. I'm going to do this later. And we will copy the full other buffer. So the idea is that we can, since our frame buffer objects are basically just information about where to place stuff, it should be easy to select subregions of that. No, it's actually not, because it's not quite easy. Okay. So yeah, we're just gonna do the more general version, and then we can still think about a more specialized version later on. So let's see. Oops, is this correct? Okay. Just gonna use this like so. It's a very long function, but basically this will be our function of how we place glyphs. And the source could be a glyph atlas, like a texture atlas, and this could be UV coordinates inside that texture atlas. And this destination typically just going to be our frame buffer, and where to place it. So first things first, we want to know how much we want to copy. So we can do basically a lot of these things again. So if our destination, the names are getting a little bit long. If our destination x is less than 0, what we need to do is crop the source width, essentially, because this tells us how much is going to be rendered, just like we did before. Also, we set our destination x to 0, but also we need to advance where we want to start copying the image. So this is going to be minus destination x. So we basically start later in the texture. We always don't forget that destination x is assumed to be negative, so this essentially is subtraction, and this is essentially an addition. So yeah, and the same goes for our y direction. So no. So that's one thing. Then we want to make sure that we have to render anything at all, like here. So if the whole region that's going to be drawn is outside anyways, we don't have to draw anything. So if we take our destination X and add whatever remains of, no, it's just the destination X. If that falls out of the destination width, we don't have to draw anything, just like in the code above, like so. And now let me think. Now we also have to maybe crop this, but I would say it makes more sense to just check whether or not this region here is a valid region inside the source frame buffer, because you somehow compute this information, and it wouldn't make sense to go out of bounds in here. So we can do a quick assert. Maybe that's a good idea, because I still haven't done it yet. So let's do the dumbest assert you can think of. It was about time, I say. Basically, we're just going to print or we're just going to assertion, assert, failed. Something like this. And we can also specify some line information maybe. Something like this. I will just implement it and then explain what it does. So first of all, I want to see if this works, and then I can explain it. So first things first, I'm just gonna go into main and just assert, because I can. So let's see. So as you can see, it didn't do anything because I haven't exited. So that's also a crucial part of assertions, is to actually quit the program, like so. So now we have assert main 224 false failed. So our assertion is false. So the formatting is a little bit screwed, but that's okay. So we can essentially add a new line here, add a comma here to be more what you would expect. Add a new line here. Maybe add an indentation here. So just a little formatting so that it's easier to read. Now we have something like assert main. So we see the function. We see the file. That's, oh, I said function. See, I'm stupid. I wanted actually the file, but maybe also the function. I don't know how to format this. So like this. Let's just give both of it. It makes it easier to find the location in your source code. Now we have something like the file, the function, and the line, and then we have the condition that failed. False failed. So condition, we can just stripe something like condition failed, condition blah 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 failed, like this. Condition false failed. Wow, that's good. And we can do that in a new line too, because it's just easier to read. So now we have assert, then we have the location, then we have the condition, and then just failed. Doesn't matter. I can put that in one line actually. And I can put in some quotes around that, so it's a little bit more readable. Condition false failed, so that's good. That's good enough for the most part, but we can also specify. Oh, I wasn't explaining anything at all, right? So let's get through this a little bit. Okay, basically, we just want to say if the expression is false, we will print out the file, which is a string. Then we print out the function, which is a string. Then we print out the line number, which is not just an integer. Then we format to the next line, write something, and then we have this hashtag or pound symbol followed by one of the arguments. This effectively will turn expression into a string. So whatever is said here will be basically, if I use false, like in the case I'm using it, if I pass assert false, it will turn into false as a string like so. And if you, in C++ and C, if you have two string literals like hello and world, without any operators or commas or anything, just separated by space, C++ will turn them into hello world. So it will automatically concatenate this. So this will be turned into a string literal, and these three string literals then will be automatically concatenated to one string, just like so, if this is a good explanation. Could anyone follow that? I don't know if I should comment on this, but basically, since I'm explaining it right here, it should be clear to everyone. So that's what it does. So this way, it's easy to tell the viewer what exactly was that failed, instead of just telling you that there was some condition that failed. You can also just print out the condition that failed. So yeah. Now that we have a quote-unquote proper assert, also, I just exit. Yeah, I just exit. That's okay. But maybe you don't want to exit automatically. You might want to trigger a debug breakpoint, and for that you can use whatever your compiler supports. For instance, in MSVC, you can just type in debug break, and this will cause your program to halt if you are in debug modus. So you can just paste this in here, and this will cause your program to halt. Oops. And then you can look at the whole context of your application. It won't work here because it will crash your program because there's no debugger hooked up. As you can see, there was a little break there before the program shut down, because it tried to call the debug break, but it couldn't. But if we were to use Visual Studio or another debugger, now the debug break will bring us to the line that caused the breakpoint. As you can see, main exe has triggered a breakpoint. And now you can inspect all the rest of your program to figure out what led to this assertion failing, which is a nice thing to have, I think. So now, with the power of assertions, we can do something like if define debug. Otherwise, if we're not in debug mode, we can define assert ... to be replaced to nothing. It's like so. So if we ever choose not to compile with debug information, all these assertions will go away. They're just a tool to help us while developing algorithms and make sure that we didn't make any mental mistakes. So these are just some sanity checks basically in our code, and also reminders on how to use specific points of the code. Like for instance, that's what we wanted to do, is go into our blit function and just assert that whatever source X we have, for instance, is between 0 and source X is also between 0 and source buffer width. Otherwise, it wouldn't make any sense. And we can have different asserts for different things, but you can also put them all in one line. But I find this more useful because this way you know which one of these conditions failed actually. So something like this, and then you want to say something like, also I want to make sure that our source x plus our source width is less or equal to our source width. And you can also check for your source width to be positive, for instance. Yeah, I mean, at least positive, for instance, like this. I might not be thinking about all the cases right now, but I would say these are the most sane cases. Basically, all you want to express is that the user of this function should make sure that these coordinates are all well-defined inside the possible space of your source frame buffer. That's our assumptions. Otherwise, the user has called the blit function just wrong. So if we have all this information, now we can go ahead and start the copying, and the copying now starts from destination y to what did I do here? Yeah, so from that to and x is just destination x plus whatever the source width that remains, and it should be less than our destination width, like so. And the same goes for our y coordinates. It's whatever destination y is plus whatever remains to be copied from our height, but not more than we can actually afford to copy. And then we have our destination y going like this, and our destination, our x going like this. And all we do is basically we have our destination base, which just takes in the iterator directly. And what we want to copy is now source base. And this time it's a little bit trickier because we have to consider maybe I do it differently. Instead of having an and, I can always start with 0, and I just calculate how much width and height we need to iterate over. So let's say width is whatever whatever the source width is minus whatever width would remain from destination to the end. So that's the width that we need to copy. Same goes for height, like so. Oops. Basically, this tells us how much width we could possibly have that we can write to, or height. And this is how much the source expects us to copy. Yeah. So and now we have our iterators going from, now we can just call them x and y, because previously I couldn't call them x and y, otherwise I would have to rename this arguments. I call them it. This time I can just call them x and y and say that they go from 0 to height and from 0 to width, like so. And now we have to assume that we always add the offset to those values. We now have to say, well, because this starts at 0, it actually should always start at where the destination y is. And the same goes for the x. And this way we have x and y separate and can use different offsets to read in the source and to write in the destination. So we can just copy this. And instead of using destination X, I can use source X. If I write it properly, like so. I use the destination width because it's also the data is different, laid out differently. So then we have this, and we just call this auto color. And then we should be able to paste it. Yeah, I already have that. And if you want to be extra sure, we should make sure that our destination base is not the same as our source base, but you know, this won't catch all the errors, but it will catch a very trivial error. So let's see if this compiles first. Base. That's not a base, it's a base. Okay, this works. Well, technically. Now we need another buffer so that we can actually test it out. So what I'm going to do is I'm just going to create another frame buffer as a texture to copy. Like I can just say something like it's 200 by 200, who cares? And what I'm going to do is I'm going to iterate over it and say, first of all, I want to clear this thing. So I want to clear it. So I want to say something like width and then I want to go through over the buffer and just generate some random pattern, like for instance a frame or something. And just say, hey, go over the X. A lot of work just to be able to test the simple functionality before we hook up a real texture, but that's a good approach to have some structured assets, basically, where you know what the content is, and then you can expect what to see. So basically, I can just say something like text. Why am I saying text buffer? Let's see. Good old test buffer base, and we want the zeroth row to be filled with a color, like for instance, good old red. We also want the last row to be filled, so it's going to be height -1. And we want, basically we want this, oops. We want the same loop also now for the y direction, so only now we iterate over the y and assume x 0, and we assume x to be with -1. Everything else should be black. Something like this. And now we can try to copy this thing. Fingers crossed. First of all, check if that didn't have any problems. It did, of course. So what don't you like about this? Text buffer. I did it again. Guys, why am I doing this? Did it again. It's still here. Oh yeah. Yeah, that's good. That makes sense. Okay, good. So we should be able to create this properly. And now we want to finally use our, after we filled everything, we want to use blit. And we want to place it somewhere, I don't know, in the middle, and specify our test buffer. And we can just specify the whole thing for now, just to see if it would work at all. I doubt it, but let's see. Oh yeah, see, it worked. First time. Works first time. It's amazing. So basically, I would say this is all we wanted to do today, but I'm just gonna check if whether or not we also copy this if it's cropped. So I'm just, again, like in the previous example, I'm just gonna say minus, let's just say we want to print half of it. So I'm just gonna say this halved. And an expressions like this is also why I want to keep the dimensions of these buffers to be signed, because I will use them all the time in other signed expressions. And so it just makes sense to assume that they are signed themselves. Otherwise, you might end up in some weird overflow problems. Yeah, I mean, yeah, I think it works quite well. So now I want to to place them outside. Let's just say whatever the frame buffer width is minus 100, whatever the frame buffer height is minus 100. Just see, I probably messed up some of the corner cases, so just see if this would make any sense. Yeah, so it copied them here, and which is weird. Well, yeah, there's also something that we haven't thought about, like where the coordinates of our buffers. As you can see, our coordinates go from expect 0, 0 to be down here, while also it works that if we resize it, that the relative position is remains, which is also something that we want. But as you can see, our coordinates go from 0, 0 in the top and the bottom left corner to whatever the dimensions of the buffer is in the top right corner. But Windows, on the other hand, works the other way around. Like 0, 0 would be up here. But I personally prefer 0, 0 to be on the bottom left, because this is a mathematically more correct way, if you like. And also a lot of modern hardware APIs reason the same way. So this is what I prefer, and which also means that if we write text, our text would go, our text cursor would go, will decrement basically in y direction if we want to write top to bottom. But I think this is a resounding success. Everything works fine, and now if we would be able to load up the font data, like for instance, if we were to use STB TrueType, we can fill out a texture buffer or a frame buffer with this data, and then we can draw subregions of it. And this is all we need for text rendering, basically. Except one thing that I haven't done yet, which is blending. But typically, you don't just want to overwrite the data, but you want to blend the data by an alpha value. But I think it's good enough for now. I have done approximately 2 hours, and while I was only able to finish half of what I was set out to do, I wasn't expecting to be done today anyway. So, but I think that's a good setup. So you can see how easy it is to just have your internal software render buffer, fill it with whatever data you have, and then figure out a way how to present that to your operating system. I did this already for you, so I just showed you how to do this instead of we working this out. And I found this to be the most promising solution for what I tried. So now I would do some Q&A if you care. Oh, yeah, the Z-Man. Thank you very much. If it helps you, that's great. Yeah. I'm open for questions now, but I'm gonna get some water first. So type in what you want, and we can go as long as you want. Why GDI is not good? Video was better than last time. I should stop apologizing, but yeah, I mean, this is just who I am. But thank you, MTX. Oh, I try to explain virtual alloc, but I'm trying to go over your points. So GDI sucks because it essentially would do whatever we do right now. So it might be hardware accelerated, but I doubt it because it's a very old API. And if it's not, then it's literally the same as us writing data ourselves. Also, the API just sucks, generally speaking. I was hesitant to implement displaying the cursor just because it's hard to get the proper information from GDI on how much your cursor basically advances. And yeah, that's the main reason. About the second part, video quality is better than last time. Yeah, that's great. I will check the video that I recorded. I assume the video is fine because the last one was also fine, but it's just my internet that's a little bit laggy. And the last question, virtual alloc. Yeah, virtual alloc. Basically, you request a virtual address space. So, but also within reason. Like, if you request more than you have RAM, this function will also fail when you use memcommit. But typically, what you do is you ask your operating system for just a range of virtual address space. And once you touch that space, so like you have to imagine memory is laid out in pages, like 4 kilobytes of data, basically. And every time you touch a page for the first time, be it reading from it or writing to it, your operating system will intercept with a hardware exception and will then, on that point, try to deliver you an actual physical page. So as long as you can request 4 gigabytes here, for instance, but if you never touch them, it won't allocate physical memory. So I hope that clarifies that. Yeah, well, virtual memory, basically hardware has some tables how to map the virtual memory range into physical range. So even if your virtual memory address space might seem contiguous, it might map to arbitrary physical addresses. Yeah, I don't really want to get into super details on that, but basically, it's a hardware feature. You have some. You can set up rights on how to read and write and execute memory, but which is all managed by your operating system. And if you ever do something the hardware does not expect, it will fault and cause a hardware exception, and your operating system can then catch that and do whatever it feels is appropriate. The reason why not OpenGL, this was just basically preference. Like the rendering part in this tutorial is not important, basically. because I wanted to talk about text editing, it doesn't really matter how you render the text, but I didn't want to continue using GDI. That's why I settled for software rendering, because all we really need is to copy regions of one texture into another without scaling or rotation or anything. And that's relatively straightforward, as you have seen here. Also, a thing that I wanted to show you that I haven't done. How about this? Just for the lols of it. For all the people who want to make maybe a pixelated indie game, they can totally do it in software rendering. And the way to do it is basically if we take our render resolution here, and we just assume that we have bigger pixels, like let's say 4 screen pixels per virtual pixel, like so. Our present should be handling this, I hope. Well, let's just see. Probably won't. Yeah, let's make this a bit better. If we specify the width and the height of the window directly, we can specify a smaller buffer that will be stretched out to the whole window. So we can go here and say the width is this. And the height is this. This is a little sidetrack, but I think it's nice to see, basically. And instead of multiplying by 4, I should divide by 4, because we want to have less pixels than our window has available. Like so. And then if I do the present command and I specify the actual window width and height, it will try to stretch the window properly. If I didn't do any mistake, yeah. Now you see maybe that everything is bigger, and this texture we only filled in 1 pixel. But if I take a screenshot and go into Paint, we can now see that actually it was stretched out to be more than 1 pixel, like so. It's 4 pixels, exactly. So if you want to make a pixelated game, all you have to do is take whatever internal resolution you want. This can be also fixed size. And at the end, you just blit it to the proper window width, and Windows will stretch it accordingly, which I find nice. So yeah. Also, it's a good debug feature for your renderer, because now you can observe the pixels in more detail, and you can basically zoom into your frame buffer and get more information. Yeah, so a little sidetrack. So what was the next question? I answered the yeah, I can check the statistics in OBS if I missed the frames, but I think it's basically, where do I see this that I missed frames? Oh, here. Yeah, 16% drop rate. Yeah, well, but I assume it's not in the recording. So yeah, let's hope for the best, people. I was wondering how to watch physical memory because I don't think it's one-to-one. Well, no, it's not one-to-one. The virtual addresses can be arbitrary per application, basically. Windows will reset the hardware if your application uses a different virtual space than another. And this is basically because we have 64-bit operating systems. The virtual address space is just gigantic, so you can do whatever you want with it. Yeah, so yeah, exactly. If we really wanted hardware acceleration, we should use just a proper API like DirectX or OpenGL or Vulkan or whatever. But it's just this is just the simplest thing you can do, and also it's you can heavily optimize it, so it's not really hard to keep it performant even if you have a lot of text. But you have to do some SIMD and all this stuff. I don't know if I have an application that I can show you. Probably not, because all the stuff that I built is probably broken by now. Let's just see. No, this doesn't work. Do I have to call it from here? I'm not sure anymore. Yeah, I mean, this is another software renderer and renders at 30 frames per second, which is not a lot, but this version was not very optimized. But basically, this is what I would be doing next, to load fonts and then to display them properly. Yeah, but you can make it run really, really well with SIMD. So yeah. Also, it's your user no longer needs any requirements, so other than your CPU. So if for some reason your graphics drivers are a little bit shitty, just like my AMD drivers are from time to time, your application won't fail just because your drivers suck if you do software rendering. Accelerated basically means you use special hardware to do computations, like your graphics card. That's what hardware accelerated means. Even though everything runs on hardware, like on the CPU, you have special purpose hardware to accelerate certain things, if that helps. Yeah, drop frame. Okay. I don't want to. Thanks, though. I almost added him as a friend. So, do you guys have any more questions? Something else that I should be talking about? I mean, we don't have to drag it on if you're done. Nothing more? I know this was a little bit more of a sidetrack and doesn't really help you all that much with text editing, but I really wanted to switch from GDI. That's a good stepping stone. If there are no more questions, Cakes, you can just start your stream and I will rate you. How does it work? I just have to type in rate and your name, right? I can stream every week, like this time. Why not? If you like, every Monday at 3 German time. I hope this helped anyone out there. Sadly, I have a lot of dropped frames, but I always have the VODs, so maybe I do a YouTube channel and upload them there. And you have, and if any one of you has some suggestions on what they want to know next, they can always talk to me about this in Discord or in the chat. Other than that, the next step will just be to use STB image, and that inline assert is cool. Yeah, I hope. I personally like to pop out a message box too, but yeah, it's a little bit more work to format that properly. But yeah. And the good thing about this assert is also that it just breaks on the proper line instead of getting deeper into your code, and then you have to go up the call stack, which is something that happens with a bad assert. I don't know where to put source out. It could be on GitHub, but since I don't really use version control for this project, other than just having every tutorial in a separate file, separate folder, it could be anywhere. I don't have a Discord, but you can check out Cake's Discord if he wants to post it in the chat. There where we hang out. Yeah. But thank you for being there, the Z-Man. I hope it was interesting to you too. I'm not going to sell this, no. This is going to be totally free, I think. It's not very well done. If I wanted to sell something, I would put in a lot more effort. I would script it, and I would condense it to the minimum required information so that people can don't have to waste their time so much. I personally wouldn't buy this tutorial. That's just what I'm saying. Yeah, why would I create a branch for every day if I can just do one commit every day, and then you have the whole history from and what changed from one tutorial to the next. So I don't see the point of making it more complicated than it is. Anyway, so as soon as you go on, Cakes, I will just rate you. I don't see you being online right now. So yeah. So of course, all this code is also something that you should separate into other files, but we can do that as we go along. But because right now it's like 500 lines of code, it's like nothing. I don't care about this being well structured. The only thing I would do is replace all these checks with asserts or another system I call require, because these should also be there in release mode. It's difficult to switch between branches. Yeah, I mean, if you don't use branches, just have your main branch and just switch between commits. I think that's easier. I'm not gonna commit every single line of code that I change, so so also this can go away. Yeah, that's awesome. My favorite part of programming. Okay. You're not on yet, right? So I'm just gonna hang out, and if anybody wants to see anything, like, I'm open for all kinds of questions. Okay, I have a Discord message. Who dares? Oh yeah. Cakes, I'm ready when you are. I will be here till the end of time, until you start your stream. Yeah, there it is. There it goes. So party. we are going to raid. Let's see, oops, wrong machine. Yeah. Did that work? Am I doing this correctly? Didn't do anything, right? How do I rate people? I'm such a noob. Can I? How do I rate, man? Do I have to be in another mode? Well, at this point, you probably will find the raid sooner than I will send you there. But yeah, let's just figure out how this works. Canal raid. That sounds good. So how did I do that? Bye, everyone.